Hi everyone, this is Abrar. Welcome to Abrar channel. Today we will be learning about Six Sigma. In Six Sigma we will be learning about measure phase. In measure phase, as you know that there are three key elements to remember. One is something called stable. Whether the process is stable or not. So for that we can use something called control chart. So control charts, it is depend upon your data. So if your data is a discrete, that's a different control chart we need to use. If your data is continuous data, you need to use a different chart. Take an example of if your data is continuous, okay, and the sampling size is only 1, or if a sampling size is greater than 8 less than or equal to 10, or if your sampling size is greater than 10. So if your sampling size, I'm talking only about the continuous data. If your sampling size is 1, then you can use IMR chart. So IMR chart, you all know, individual moving range chart, or if your sampling data is between these range, you can use X bar R chart. X bar meaning like X double bar meaning like grand average of a process. If your sampling size is greater than 10, then you can use X double bar and S chart. So it all depend upon your data what you have. The next thing is, once you determine whether your process is stable or not, the next stage is the stability, capability. So to check whether the process is capable or not, so we can use something called CP or CPK. CP mean process capability ratio, CPK meaning like process capability index. This is something we will be exploring more in this video. The next thing is your data. So we can use a different thing for normal distributions and all these. We can use various other thing called histogram or quartile, box plot. So all of these things we will mull over in the next upcoming video, but today I would like to touch upon mainly on these charts, CP and CPK. So let's get started. What is mean by CP? CP formula you all remember that CP equal to USL minus LSL by 6 sigma. So USL and LSL is the specification given by the customer. So whereas CPK is minimum of, you can use USL minus X double bar by 3 sigma, comma, or you can also use X double bar minus LSL by 3 sigma. Now let me tell you what's the main difference between these two. So this capability CP compares only the overall variability, within the customer specification. Let's assume that you have the customer specification. So this is your line, this is your USL, this is your LSL. And the customer specifications to make one particular thing is let's say 10 centimeter diameter you need to make rain gauge. and it has a tolerance of 10. So that means you can flip the range between 9 and 11. 9 and 11. So this is your LSL and USL. So you can put it like 9, and the actual specification target line is 10, and then the USL is 11. So that means all of these values, if it falls here, so everything you're comparing only with the customer specifications. So anything within this range, the parts are acceptable. So CP compares only with respect to customer specification, whereas CPK, it goes one step further down. It also talks about something called X bar, meaning like process grand average, grand and overall average. So that means we also get to know whether my process is center or not. In order to find whether my process is center or not, so CPK can be used. Let me give an example. Here you see, here I am also using the word X double bar, the process mean, and then you can compare this value. If your bell curve is something like this, that means let's say it's a 6 sigma. That means that your values and process are well within the specification. It mainly talks about the centerness of the process. But whereas in this particular case, CP, the only downfall of CP, let's say your specification, you're meeting the specification like this. Though you're making use of only your values are between 9 to 10, most of the values are between 9 to 10, is still it is acceptable, but the rejection chances are pretty much higher. What will happen? Anything goes beyond this one, all of these values will turn into rejection, meaning like let's say you end up producing 8.9, that will go rejection, 8.8, that will go rejection, anything out of these spectrum will go rejections. So in order to make the process centralized, make the process in the center, CPK we need to use. Why we need to use a CPK? The very important aspect is it takes X bar into equation, the process average into equation. By comparing this one, so what we'll get to know, we'll get to know whether my process is pretty much capable or not. So that's the key benefit of process capability. Let's learn what is the value called 0.33, 0.66 in this upcoming video. You can also determine the sigma value by knowing the CP or CPK value. Let's get started. CP, CPK, and what's the sigma level? Let's say your CP is 0.33 and also CPK is 0.33. That means the process is centered. The bell curve, both the things will come in the center way. That means it's a 1 sigma. And if your CP is 0.66 and both are 0.66, that means it's a 2 sigma. And it's a 0.99 and it means it's a 3 sigma. If it is 1.33, it's a 4 sigma, and it goes all the way 1.66, that means it's 5 sigma, and 2, it's a 6 sigma. So that means in order to have a 6 sigma, the CP and CPK value minimum should be 2. Let me explain how we can calculate by applying formula. Let's say CP equal to CPK, let me take one value called 2. I'll determine 6 sigma. Let me take another value is 0.99. Let's see how it can. So let me take 2. So CP is, the value is, I'm just applying CP value. CPK is USL minus X double bar by 3 sigma. I'm just taking only one. So if 2 USL, I don't know, I can keep it as USL. X double bar, I'm gonna keep it as 0. Why? Because if CP and CPK falls on the same line, if they are equal, that means they are center. They fall on the same region. So I'm applying 0 by 3 sigma. So USL by 3 sigma equal to 2. So that means it's a 6 sigma. So that's how we can, by knowing these value, you can also determine 6 sigma also as well. Let me take one more example of 0.99. Instead of this, I'm going to apply 0.99 or 1 I can apply. Let's say CP and CPK is equal to 1. So 1, 1, 1. So USL equal to 3 sigma. So if the value is 1, that means is a 3 sigma. So what the key point we need to notice is anything below 1, that means the process is not capable. It can give more rejections to it. So in order to have a good healthier process, it must be greater than 1. That means we will go to higher sigma like 4 sigma, 5 sigma and 6 sigma and so on. So thank you so much for watching this video. Please like and subscribe.